Hello, everybody from Earth and Space Science. This is Miss Peachy, your WCA Earth and Space Science teacher. And today I'm going to be doing a video tutorial for your last portfolio of the school year, Math Rocks the Earth Acceleration, which is on your planner beginning on Wednesday the 19th. It's a 2-day portfolio. It shouldn't take you more than about 15 minutes, so hopefully you can finish it within just a short period of time. So let me explain what you're going to need to do for this. There's some calculations involved here. All right, so what you're going to need to do is you are going to basically just solve a few problems. Talks a bit about acceleration, a bit about velocity, and kind of how you measure them here. Because as we're looking through space, we're looking at how things move. We're kind of getting used to these units of measure, getting used to the difference between a velocity, acceleration, and so on and so forth. So let me just move this little guy kind of out of the way here. There we go. You can go bye-bye for now. I am just going to kind of show you a little bit about velocity and acceleration on the whiteboard here, hopefully. So velocity, right, is equal to distance divided by time. So how long it takes you to go somewhere, basically. The quicker you're moving, the shorter amount of time it's going to take you to travel the same distance. Where acceleration is our change in velocity over time, over change in time. So we take our change in velocity, we usually take the velocity of how we ended up, which we will call V2, as our final velocity, minus the initial velocity, we'll call V1, and divide that by time. Oh, there's an I in there. So again, you need to kind of look at both velocities. How fast was I going to start with, and how fast did I end it up to get our acceleration? So that's kind of like the math involved in the formulas for velocity and acceleration. Now let's look at the units a little bit here. So since velocity is distance divided by time, then our units are going to be some sort of a unit of distance divided by some sort of a unit of time. Typically, we see things like meters over seconds, meters per second, which we abbreviate like that. Or you might see something like miles per hour, or oftentimes kilometers per hour. Okay? That might be another unit that you'll see for velocity. For acceleration, we are going to have a velocity unit, one of these guys up here, divided by a time unit. So you might see meters per second divided by seconds. So I say meters per second. Or you might see meters, let's go back, kilometers per hour divided by seconds. So those are two typical acceleration units that you might see. And we're going to use kind of both of them in some of the problems that you're doing here. So, oops. Sorry about that. There we go. Having some issues with my mouse, doing some extra random clicking, which isn't good for anybody. All right. So we're going to go on to the next slide because it gives you the activity, and this is what you need to do. You need to do questions 1 through 4 from the activity, and you need to submit the answers and the work. So this is going to be like the HalfLife Lab people. If you do not submit any work to me, you only get like really small amount of credit. So I need to see the work. You can't just have answers. You have to have the writing. You can do this on just a piece of paper and take a picture of it and upload that picture. You can do them on your phone, take a picture with your phone, and then use your phone to email yourself, and then save that picture from your email to the computer, and then upload it to your Dropbox. That's pretty easy. Or you can, take your picture, use your webcam, hold it in front of your webcam, and just take a screenshot if you have to do that. Or you can just type in your work on a Word document or something and save it that way. But you do have to have work shown. Otherwise, you don't get credit for it. I need to see that you know how you're you're doing it. So the first question says your rocket takes off from Earth and goes from 0 meters per second to 560 meters per second in the first 7 seconds of flight. What is your acceleration? This is part of my mouse problem. I'm just going to highlight this and copy it so that when we look at this page, we can see better. I don't have to. All right, so I'm going to put it right over here. There we go. There's our problem. All right. So we have two velocities. We have v2 and v1, right? So here's our v2. So what we ended up with, 560. We started off at 0. So we are going to take our 560 v2 minus v1. Well, 560 minus 0 is just 560, right? So that's pretty easy. We're just going to do that part right away. Simplify it right away. Then it says, and it takes us 7 seconds to do this, right? So let's just divide this by 7 seconds. Okay, so now we've kind of set this problem up. You need to solve it. And our units are going to be like this, right? Meters per second. I don't know if I can have a pointer. Can't use my pointer. Meters per second, same. So you solve it, you give me the correct units. Okay. Can I erase that one? Sorry, I make sound effects sometimes. That's just for funsies. Let me get rid of this thing. Oh, there we go. Delete. There we go. Let's look at the second problem, shall we? Put it on the sheet. Click. Control V. All right. Come here. Oh, I'm moving myself, but there we go. All right, so once your rocket reaches space, the captain goes from 24 kilometers per hour to 24,000. Whoa, that's fast. Kilometers per hour to 17,000 kilometers per hour over 90 seconds. Right? So we have, let's look at our different units here again of acceleration or of velocity. These are both velocity units. So we started off with our first one, V1, is 17,000, right? And V2 is this 24,000. So let's write that one down. V2, 24,000. Right? So it goes from, no, I take that back. Boom, 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 boom. All right. It says it goes, you started at 24,000 and you ended up at 17,000. Oh, that's different, right? So our V2 is a 17. And our V1 is a 24. Ooh. So V2 is 17,000 kilometers per hour minus 24,000 kilometers per hour. So you are correct in noticing that this is going to be a negative number because we're going to be slowing down here, right? So that's okay that it's negative. So 17 minus 24 is negative 7,000, right? Yes. And then our unit for time, let's do orange, is 90 seconds, right? So you take this, divide it by 90 seconds, okay? And now you have to solve it. You have to do the math and finish this up here. And remember that our units for acceleration can be this or this. So make sure you include the correct units, because you'll get points off if you don't have the correct units. So solve and give us the correct units. Just going to get all this. Just going to undo everything we just did. There. I just want to get this out of here. All right. Let's do the next problem. We can set up problem 3. Okay, I have to control V. All right. So, once you land on Mars, you get to your rover to begin exploring the surface. That sounds like fun. Your rover accelerates at a pace of 3.5 kilometers per hour per second for 10 seconds. What's the velocity of your rover after 10 seconds? This is a bit trickier. So you're solving for velocity here. So we're going to kind of simplify this equation right here. We're going to say that when you start from rest, you can get rid of the V1. So when you're starting from like not moving at all, it doesn't matter because you're starting from 0. So V1 is going to always be 0. So we're just going to say acceleration is velocity divided by time. It's going to make this part just a little simpler for this one. But we have acceleration. We want to solve for velocity. So we're going to have to solve for velocity. We're going to have to multiply both sides of this times t. It's going to cancel out over there. So we're going to say acceleration times time is equal to velocity. Okay, that's what we're going to use for our equation. So now we just got to figure out which ones are acceleration. So acceleration, it says 3.5 kilometers per hour per second. Let's write that one down. 3.5 kilometers per hour per second times time, which is 10 seconds, is equal to velocity. Okay. So the units that are going to cancel here are seconds and seconds. Those cancel. So we can get rid of them and we can keep our final unit in kilometers per hour. I'm going to keep that as the final unit. So all you have to do is multiply the 3.5 kilometers per hour times 10 to get your velocity and report your answer. Okay? Hint, I'm really helping you a lot with this portfolio. So if you took the time to watch the video, this is going to be very beneficial to you. All right, so we have one more problem to work on here. Clean this all up. Get rid of this guy. And let's do our final problem. All right. Light travels at 300,000 kilometers per second. Super fast. Mars is 56 million kilometers from Earth. How many seconds does it take light to travel from Mars to Earth? So we are looking at the first equation here. We haven't really used that one yet, right? So we need to know this guy. We have the velocity. And we have the distance. We need the time. So we need to rearrange this equation to solve for time. So when we do that, we need to multiply both sides. It's kind of tricky. We're going to multiply both sides by time, and then I'm just going to rearrange it for you. So velocity is distance divided by time. If we multiply both sides times time, TV, you get TV is equal to distance. But we don't want that. We want time. So we're going to then divide both sides by velocity. So we end up with time equals distance divided by velocity. Okay? Think about it. Distance divided by velocity. That's equal to time. This is what you're going to need to use here. Okay. So our distance, 56 million. Our velocity, 300,000. So take 56 million and divide it by 300,000. Now the units are a bit tricky because kilometers cancel. So you get per hour. Weird, right? Whenever you have a fraction in the denominator, it becomes the reciprocal, right? So the units here are just going to be hours. So take the 56 million divided by 300,000 and your units are going to be hours. Oh, kilometers. My speech is screwed up. It's actually, this is per second. It doesn't really matter, but kilometers per second. So your units are going to be seconds because it says how many seconds does it take. So that makes more sense. Okay, that is it. That's all you have to do is to complete those 4 problems. You can solve them. We set them up for you. Show me the work. We did it together here, right? So you can show it to me because we're doing it right next to me on the screen. So finish that up. Send it to me. Again, you can do it yourself on a piece of paper. Take a picture of that, scan it, or you can write it on, a computer and do that. This is a really cool thing. If you have the Microsoft on your computer, there's Microsoft Whiteboard. So there's lots of different ways in which you can do this, but that's what you need to do for me. And once you are done, then this portfolio is complete. So thank you all. If you have any questions, let me know. Otherwise, good luck, and I am looking forward to receiving your work. Have a great day.